Hello everyone, welcome to our pre-calculus pre-recording video. This is our first lesson for this semester, a brief introduction to trigonometry. So in this lesson we will introduce trigonometry and discuss some basic concepts of this thing, trigonometry. So let's begin. First question is, what is a trigonometry? The word actually comes from, if you look at the word trigonometry, if we look at that, there are some tri, that means three, mono, di, tri. If you think about that, mono means one, di means two, tri means three, quad means four, like that. So tri means three, gono means sides, and metri means measurement. Measurement. So three sides measurement. Of course, the word breakdown is will not completely define it, but it gives us the sense from where it came and how these things is developed in the first place. So three sides related, that figure is actually triangle, and more specifically right angle triangle that trigonometry deals with. Trigonometry actually deals with the three-sided figure, that one which is right angle triangle. But in the development of the trigonometry, of course, it is not confined within a triangle. Now it can actually work with the angle, where there is some angle related, that kind of figures also, and more specifically circles also it can work with, because in the circle we have center angle, and how the angles are related when the side length increases or decreases, we can measure it. So this is the formal definition. It is the study of angles and sides of triangle and circle also. So it is included, and this is the history one, just brief history. Of course, this is not a complete one. Uh, back as 3rd century BC, which is before Common Era. But before this also there is some evidence that people used to use the trigonometry. For example, Babylonian mathematicians or Egyptian mathematicians in some capacity, of course not a rigorous trigonometry, because later after the Greek mathematicians, the Indian mathematicians and the Islamic mathematicians, they actually uh, developed this branch a lot. Okay, so that's the briefest history of trigonometry. So it came from Babylon, and Babylon is currently in Iraq. Then the Egyptian, then Greek, then Indian, then Islamic mathematicians, then goes to Europe, then again now this modern time, it is everywhere. So that's the history. And where do you use it, trigonometry? To find out the distance in the astronomy. Look, the thing is, trigonometry, this angle and the ratio, all these things actually helps us to understand if about the distance, about the movement of distant star. At that time, the Greek mathematicians and other people actually, they were interested about that thing. So they thought that, okay, let's do some calculation, and if we can get some idea about those objects there. So this is how, that was the motivation why they started it in the first place. Then describe the behavior of waves. This also we can explain by using the trigonometry. This is actually somewhat related to the circle or circular motion kind of. Okay, uh, we will study all of them. We will study all of them. Some of the things are related to the triangle, ratio of the sides and the angle. Another branch is like sine graph, cross graph. If there is like this kind of wave, we can study them in the trigonometry. Okay, so we can apply both of these concepts in different fields. So that's the beginning of the trigonometry. Let's now look at some basic concepts that you already may have, and we are just brushing up those concepts. Properties of a triangle. So of course we'll discuss with the right angle triangle or right triangle. What is the area? Area of a right triangle is half into base into height. Let me draw a figure. Let's say this is a rectangle. What is the area of this rectangle if this is length and this is breadth, or this is width? Area is length into width, right? This is the area of the rectangle. Now you see, if we draw a line through the middle, then actually this is a right triangle. This is a right triangle. And what is the area of this right triangle? This right triangle. This half of the full figure, right? Because this line divides the full figure into two parts. That means this will be half of whatever it is. So half into whatever it is, L into B. That's what the area of triangle is, half into base into height. This is the base, this is the height. Okay, this is the base into this is the height. So this is the area of the triangle. Now you can say, oh, other half is here. That's true. So this is the half, this is another half of the rectangle. So rectangle is length into breadth, and triangle is half into length into breadth, because this line divides the rectangle into two halves. That is the reason. Yeah, so total sum of the all angles of a triangle. This is we will just talk about this. If you add all the angles inside a triangle, it will always make 180 degree. And right angle means this one angle is always 90 degree. This angle is 90 degree. One angle has to be 90 degree to become a right angle. This is the Pythagorean theorem. For right angle triangle, you can apply it. Only for right angle triangle you can apply it. C square equal to A square plus B square. That means C is the length of the hypotenuse. This is the largest side. This is called the hypotenuse. And this is one side, this is another side. Okay, this is one side, this is another side. So hypotenuse is square equal to sum of other two sides is square. It doesn't matter which side you consider B or which side you consider C in this formula. But C is very fixed. C, hypotenuse is the largest side always, but other two sides we can choose by ourselves. And in this figure, you will never know which one is base and which one is the perpendicular, or which one is adjacent, which one is the opposite, because the angle is not given, which we will discuss in this page. So see, this is the right angle triangle. First of all, this is the 90 degree. So this is the largest side. So this must be the hypotenuse. Now, sometimes when we ask the students, like suppose, let's say, now look, in this case, this is clear that this is the base, right? This is base, base, and this is perpendicular. Perpendicular means opposite. This is the hypotenuse. But if this is the 90 degree, which one is base here? Now the triangle is somewhat, if you look from this side, then this looks like this is the base, and if you look from this side, then it looks like this is the base. So which one is base here? Actually, the concept is not like which one is down here, that is base. This is not the concept. Concept is, where is this angle given? Where is this angle given? Angle is given here, so this must be the base, and angle is given in this corner, so this is the opposite side of the angle. That's why it is called opposite. Okay, This is the opposite side of the angle. Angle is given here. So this is the opposite side of the angle. Okay. So if they don't give the angle here, if they give the angle in this side, in this case, this will become the adjacent or base. If they give the angle here, then this will become the adjacent or base, and this will become the opposite. So in this figure, if we give the theta here, suppose, then this will be our adjacent, because this is the side which is with the theta. Now you can say, sir, oh, this side is also with the theta, but this side is already out of our consideration because this is 90 degree, so this is the hypotenuse. Hypotenuse is always the largest side. Hypotenuse is always against the 90 degree, so already we know that. Okay, there is no debate about it. So this is the adjacent or base, whatever you say, and this is the opposite if the theta is given here, because this is the side with the theta. So this is called adjacent. Adjacent means something which is near, which is close, and this is true. This side is near to the theta. Okay, and this side is opposite. This side is opposite. Theta is there, so this is the opposite. So this is how you can figure out. Now we have a basic trigonometric function which relates the ratio of the side of the triangle with the theta, and the definition is sin theta is opposite divided by hypotenuse. This is the opposite divided by hypotenuse. Cos theta is adjacent divided by hypotenuse, and tan theta is opposite divided by adjacent. There is a nice mnemonic to memorize it if you want to keep it in mind. This is called SOHCAHTOA. So S-O-H, so C-A-H, ka, T-O-A, SOHCAHTOA. So see, sin theta equal to opposite by hypotenuse, cos theta equals to adjacent by hypotenuse, tan theta equals to opposite by adjacent. So to keep it in mind, this is a nice little line. SOHCAHTOA, S-O-H, SOHCAHTOA, SOHCAHTOA. And if we reverse it, suppose this is opposite divided by hypotenuse, so if we say, okay, hypotenuse divided by opposite equals to what? Or this is adjacent divided by hypotenuse, then hypotenuse divided by adjacent equals to what? And for that reason, we have three more. They are cosecant, secant, and tangent. So sine, and for sine it comes cosec, for cos it comes sec, for tan it comes cot, when you just alter the numerator and denominator of this right side. That means this is opposite by hypotenuse, so if you write hypotenuse by opposite, it becomes cosec. This is adjacent by hypotenuse, so if you write hypotenuse by adjacent, it becomes a sec. This is opposite by adjacent. If you write adjacent by opposite, then it becomes cot. It's right cot. And there is only this 6 trigonometric ratio, by the way. There is no more. Only this 6. Okay. So if we study only this 6, that's the complete study. Okay. And what is the reason why there is only this 6? Why more is not possible? You can think about it. This is an application of the concept that we learned about those formula. So you see, this is a high-rise building. Now, if you know the base is 50, what is the height? And the theta is given. Let's say theta is 73 degree. So how can we use it? So basically, you see, we are. Let's see. This side is given, and we will have to find out this side. So which formula is related to this base and this opposite? That is tan theta. Okay, so you write tan theta formula, then you write angle value. This is the height which we will have to find out. Tan theta equals to this opposite divided by adjacent. So opposite we will have to find out in this case, y divided by x. So x value you write. Now from the calculator you find tan 30 equals to what? In the calculator you write you will get this value. Then you just do the cross multiplication to find out the answer. So you see, by using this formula, if you know this angle, and the base, without climbing to that building, you can find out the height of the building. So that's the use of this formula. Another nice use of this formula is, let's say you have a river here. Suppose you have a river here. Now you are here in this side of the in this side of the river. You are here in this side, and it's a big river. And then there is another your friend somewhere in the other bank of the river. Now he knows some things height here. He knows, let's say, some tall building here, eh, and he knows the height of this building. And from here, somehow you can measure the angle with the top of this building, with the top of that building. Somehow you can measure the top, measure this angle. Somehow you can measure this angle. Now you can measure this angle. Somehow means basically if you do the eye estimation like this, you put a scale here and you can think about, look, okay, what is this angle? What is this angle? Then actually you can adjust it, and there will be some error, of course, but you can estimate it. Okay, so this angle you can find out by eye estimation. And then there is one friend of yours in the other side, so he can tell you the what is the height of this structure, what is the height of this plant, tree, or building, whatever it is. Then if you know the height and if you know the angle, you can actually measure the how much, what is the width of this river without swimming it, without measuring it with a tape, without doing anything on the river. You can actually measure what is the width of the river. So this is nice, because you will not have to get wet or swim there to find it out. So this is nice, I think. Measuring angles. So how do we measure angle? And this is also basic, one of the basic concepts that you may already have. This is one initial side, and then so we will have to fix something, right? First of all, let's say we fixed it. This is our fixed side or initial side. Then you move this line, you move here, then actually in the center one angle is made. Angle is increasing, angle is increasing, angle is increasing. Okay, so basically one side, and then terminal side is this one. This one is terminal side. This makes an angle in the center. This is the intersection is called the vertex. Okay, and this theta we can measure, we can tell by alpha, beta, theta, etc., etc. We can say it about that. And in trigonometry, we can actually, this is important actually. We always measure the theta anti-clockwise. Okay, clock is this way, anti-clockwise is the other way. So we always measure it in the anti-clockwise direction. So that's the positive angle direction. Okay, positive angle direction is always anti-clockwise this way. Suppose here to here it is, let's say 120 degree, so you will just say 120 degree. But if it comes this way, then it will be minus 120 degree here. That will become, suppose somewhere here. If you come this way, in the opposite way, then it will become minus 120 degree. That's the convention how we measure the angle. Terminal side, and if it goes one rotation, this is 360 degree. Properties of a circle. So it's a circle. This is the radius. Radius is the distance from the center to the circumference. Diameter is the distance from one side to the other side when the line goes through the center. This is the diameter. So that means diameter is the double of the radius, because this is one half, this is another half. Chord is not given here. If we give the chord is actually any other line which which touches two sides of the circumference, which touches at 2 points, at 2 different points of the circumference, but do not goes through the center. Then it is called chord. So these are the definitions of couple of things about the circle. And circumference of the circle is 2 pi r. This is pi times the diameter. This diameter is d, and pi times the diameter is the total circumference. Length, this is actually length. Circumference is the length, and if the diameter increases, as you can see it from here, circle also the circle circumference also increases. Okay, circumference of those also increases. There are, of course, nice little proof of all these things. How they come. If you're interested, we can discuss it during the class or some other time also. So measuring the unit circle. Unit circle means if the measuring angles using a circle. So we will start with the unit circle, but let's just talk in general here. Angle, right? Angle here. So you have the initial side and the terminal side, then this is the angle. And then you measure it actually here. This is like one box is 90 degree, another box is 90 degree, another box is 90 degree, another box is 90 degree. So total 360 degree. And this one to this one 180, another 180. So again 360 degree. So here we define there are two ways to measure the angle. One is theta, another one is radian. One is degree, another one is radian. Theta is actually just a symbol. One is what? One is degree, another one is radian. What is a radian? So the definition of radian is if you have in a circle, if you have the length of the radius is let's say 2 unit, length of the radius is 2, and then this side is also 2, as you can say. It will be 1 radian in the center if and only if the length of this arc is also 2. So the length of the same radius and arc makes 1 radian in the center. Now it can be 1 centimeter, and if this side is also 1 centimeter, now you can say, sir, why if this side is 1 centimeter? Of course, this can be less than 1 centimeter or more than 1 centimeter. Then it is not 1 radian, then it is less than 1 radian or more than 1 radian. Okay, so we define it like, okay, let's say this side, this is circular, of course, and this side, all are same. Okay, then consider it 1. This is how the definition is developed. Okay, they said, okay, this consider this side and this side and this, all of them same. It do not have to be 1 1 1. It can be 2 2 2. It can be 5 5 5. It can be 10 10 10. Same. Then the angle subtended in the center will be 1 radian. Hey, how can it be not only 1? It can be 10 10 10. The reason is when you increase this side 10, then this side also increases by 10. This side also increases by 10. And angle in the center remains the same. Do you get it? Like, yeah, I'm sure. I think you get it. Suppose it increases, then it also increases, then it also increases. So basically, the angle remains the same in the center. So this is how we define the radian. Radian is actually the equal length of arc. This is called arc length. This one is called arc length. This is the arc from here to here. If we take it from the circumference of a circle, some small part, this is called arc. If the arc length is same with the radius, this is called 1 radian. The angle inside the center is 1 radian. And the relationship between degree and the radian is total in the degree measurement we have 360 degree, and in the radian measurement total we have 2 pi radian inside the circle. Okay, the how it come here, how these things comes here. The reason is, see how we get it, how we get this one. The rule is the length of this circumference divided by the radius. This is equal to 1. So this is why 1 radian. Okay, now if this circular part increases, then what will happen? So let's think about it. How much? This is the arc, this is the radius. So think about it, how much it can increase from here to all the way around. What is the total length here? Total length is 2 pi r. That is the circumference of the circle. Okay, good idea. Then divide it by the radius of the circle. So radius is r. So what we have here? We have 2 pi radian. This is how we have total 2 pi radian inside a circle. So that means 2 pi radian is the total in terms of radian, but the same thing in terms of degree, it is 360 degree. That's why 360 degree equals to 2 pi radian. Then we can say that, okay, 1 radian equals to, we can just do the calculation for this part. So 1 radian equals to pi radian equals to 180 degree. We divide by 2 both sides, then we get another formula. Then 1 equals to 360 divided by pi. Then 1 equals to what? These things actually, from here we can develop all this nice small and small formula. These are common values of trigonometric function, like say sine 30 degree equals to what, cosine 40 degree equals 45 degree equals to what, and this degree, that degree equals to what. These are common values of trigonometric functions that comes with within square root, of course, nice little number that we can sometimes keep it in mind. That helps, but this is not necessary that you will have to keep it in mind. Okay. And in someday, this is introductory class, of course, basic class. So in someday I will prove or show how this value comes, at least for sine, cosine, or tan, at least from any one of them. Okay, we can prove it, like how this value comes in some other time. But these are very commonly used. Okay, these are very commonly used. So you will have to get some familiarity with this thing. Now comes another important thing. This is called trigonometric function on the unit circle. Now at any instant when it moves, see, this is like how you get the, this is right angle always, and how you get the, how your angle increases. This is how it increases. Unit circle means if the distance from here to here is 1 unit, this is called unit circle. If the radius is 1, this is called unit circle. And the interesting thing here is, see, if I can stop this this thing at any place, let me try it. Of course we cannot do it. Let's say, suppose here we stopped it, and then it goes somewhere here, it goes somewhere, it comes somewhere here. Okay, it will come, you will see. Let's say this is our 90 degree and the other one is our theta. It comes here, right? Yeah, it comes here. So see, we will not try to prove any rigorous thing here, but just to show you how this equation comes. This is x, this is y. So you see, based on the Pythagorean theorem, we said that Pythagorean theorem is c square equal to a square plus b square. And we know for sure that this is 1 because the whole circle is unit circle. So the radius is 1. So that means x square plus y square equals to 1 square, which gives us x square plus y square equal to 1. So this is true for unit circle. Okay, unit circle is very helpful for defining couple of other things. See how it works. See, for the unit circle, Sin theta, cos theta, tan theta, sec theta, or cot theta. All of these things we can define. This side is x, this side is y. We are just supposing it. You can say, okay, this side is p, this side is q. No problem. And most important thing here is radius is 1. Radius is 1. How it helps? It helps this way. Now, if you take sin theta from this figure, sin theta equals to, we have learned from the ratio, SOHCAHTOA, sin theta equals to opposite by hypotenuse. That means y divided by hypotenuse. Hypotenuse is 1. So y divided by 1. That means y. That means y. So this is the y. And cos theta gives a, cos theta is x because adjacent divided by hypotenuse, so it becomes x. Adjacent is x divided by 1, so that is x, which is actually this point. Because from here you go and then you go here, the coordinate of this point will be x comma y. Think about it in the coordinate system. So basically it actually gives us a very interesting thing, and that is, if this values is given in a unit circle, if this value is given in a unit circle, this point will represent something interesting, and that is this value and this value is given. Let me write some value. Suppose this value is, let's say something, let me give some real value, 30 degree. Let me give some real value. Let's write here 1 by 2 and here root 3 by 2. Suppose, of course this is true, I'm writing it actually for 30 degree here. Suppose these values are given here in this point. What it will mean? It will mean that, see, y equal to sin theta. So it will mean that sin theta equal to half. Automatically it will mean cos theta equal to root 3 by 2. Okay? And if you know the theta, of course I already said this is 30 degree in this case, and it will match with everything actually. Even if you do not know the theta, by using this value you can find it out. We can find it out. We will show you all this application. But this is interesting actually. This is useful also. If it is a unit circle, you have a point here. The first value represents the cos theta value, second value represents the sin theta value. So how do we get the tan theta? You divide by sin theta divided by cos theta. That means this value divided by this value. Y divided by x. Y is sin theta divided by cos theta. So you divide this value by this value and you get the tan theta value. Okay. This way, if it is unit circle, we can actually find out a lot of things. Okay. And here also it comes. See, first one is cos theta, second one is sin theta, etc., etc. Now, if it is radius is 1, then okay, fine, this is sin cos. If radius is 2, what will happen? Just you multiply this cos theta by 2, sin theta by 2, finished. If it is 2. If it is 3, it will be 3, it will also be 3. That means 3 here, 3 here, if it is 3. So this way it will work. Now see, this is the use of that. First one is what? Cos theta or sin theta. The first one is cos theta, second one is sin theta. So we can actually work with this thing. Cos theta equals to what? Sin theta equals to what from it. This kind of math we will do in the class. That's why we will not solve fully this math here. You can give a try. And this is the last page of our today's pre-recording. You can have a look in this kind of more videos, or these are the from the book if you want to practice. This is a chapter, like this is the book. If you have the printed book or if you have the PDF book is shared with the class in the Google Classroom, so you can have a look. This is chapter 6 if you want to study it. And 6.2 is 6.2 is we actually discussed something from 6.1 also, even more basic also we discussed here in this in this video, but rigorous or very important concepts actually starts in 6.2. We will solve the maths from 6.2 in the class. That's where we will start. So that's all for today. Thank you all. Thank you very much. Have a good day, everyone, and see you all in the class.